everybody. It's Friday, May 1st. Hope everybody's doing well. And I'm going to show you functions and inverse functions this morning. In order to be a function, graphically speaking, it has to pass the vertical line test. In order to be a one-to-one function, it has to pass the horizontal line test. And I taught you that earlier in the semester when we were actually in school. So some functions have an inverse function and some functions do not. It has to be a one-to-one function in order for the function to have an inverse function. So every element in a domain, the x values, every element in a domain has to be assigned a unique value. If not every element in a domain is getting assigned a unique value, it is not one-to-one and it will not have an inverse function. So a function has to be one-to-one in order to have an inverse function. A quick example of some characteristics about a function and its inverse. Say we have a simple function f of x equals 2x minus 1, which if we do a little table of that and graph that out, some 3 points that are on this function are -1, -3, 0, -1, and 1, 1. So if we plot that, -1, -3, 0, -1, and 1, 1, this function is linear. It's in slope-intercept form. Anyways, that's what that looks like. And if you'll notice, so yes, this is a function because it passes a vertical line test. Yes, it's one-to-one because it passes a horizontal line test. So this guy will have an inverse function. And I've noticed if you get the table for the function and it has an inverse function, all you have to do to get the points on the inverse function is interchange your variables. The domain in the original function will be the range in the inverse function and vice versa. So you just flip-flop your coordinates. So if I were to graph out the inverse function, and notice the inverse function, if my function is f of x, the inverse function is labeled f to the -1x. So anytime you see that notation, that is the inverse function. If I plot these points, -3, -1, -1, 0, and 1, 1, my inverse function looks like this. And I didn't draw that very well. But anyways, the point that I'm trying to show here is that pretty much every single time a function and its inverse function will have a reflection through the line y equals x or y equals -x. It's going to split that. So in other words, I don't know how it's gonna be a reflection across that line y equals x or y equals -x. Y equals x is known as the identity function. So if you know a table for your original function, you automatically know the table for the inverse function because you just interchange the coordinates. So the domain in the original function is the range in the inverse function and vice versa. So what they're going to do is they're going to give you a function, and then algebraically you're going to have to find its inverse function. Alright? So they'll say, given some function, find its inverse. So given, say, g of x equals -3x minus 4, find the inverse function. Alright, so to do this algebraically without a calculator or without making an xy table, what you do is you write this function like you used to see it in algebra 1 and 2. So put y in for the g of x because y is a function of x, y and g of x are the same thing. So write y equals -3x minus 4. So write it like you used to see it all the time. Once you do that, then interchange your variables. when I say interchange variables, you know, put x where the y was at and put y where x is at. Once you interchange your variables, solve that equation for y. So I move the -4 over, change sides, and then of course to get the y by itself and positive, I'm going to have to divide by the -3. So once you have done that whole process, this guy right here is or will be your inverse function. And so my function was g, so how do I label the inverse function? I'm going to write g to the -1x. So you replace the y with, you know, g to the -1x, or if your function was f of x, of course it'd be f to the -1x, or so forth. And x plus 4 over -3 can be written like that, of course. You can just leave it like that verbatim. Or you could write -1/3 x minus 4/3. Either way you go, you know, x plus 4 all divided by -3 and this guy right here are the exact same thing. So I'm going to do one more, and that is how you, you know, these are the steps algebraically given a function on how to find an inverse function. And as I said, if we were to graph that out, the function and the inverse function would have a line of symmetry, through the identity function y equals x, or sometimes they have a line of symmetry through the line y equals -x. All right. One more. But functions and inverse functions are a big deal in college algebra and any math class, college algebra and higher. I'll talk a little bit more about that here in just a second. So one more like this. Given h of x equals 5x plus 2, find the inverse function. Alright, well, as I said, write it like you used to see it when you were a freshman and sophomore in Algebra 1 and Algebra 2. So instead of writing h of x equals, write y equals 5x plus 2, because y and h of x are the same thing. Y is a function of x. So we write it like we used to see it. Once we do that, we interchange our variables, put x where y is at, and put y where x is at. Once you interchange your variables, you have to solve for the variable y, get y by itself and positive. Change sides, change signs. Divide by 5. So y equals x minus 2 over 5. That is my inverse function. So how do I label the inverse function? Well, my function was h of x, so my inverse function is going to be h to the -1x. So once you get the y by itself and positive, you put the inverse notation in for your y, h to the -1x. That denotes that that guy is your inverse function. And you can either write your answer as x minus 2 over 5, that would be perfect, or you could do what most college professors would have you write, and that would be, in this case, 1/5 x minus 2/5. Because as we should know, any quantity over a common denominator can be split into pieces, and any set of fractions that have a common denominator that are separated out can be written all over the common denominator. You can go either way with it. So given this function, that guy right there would be the inverse function. And as I said, if I did a quick table on this guy, say -1, 0, and 1. If we plug in -1 for x, that'd be -5. -5 plus 2 is -3. If we plug in 0 for x, 0 times 5 is 0. 0 plus 2 is 2. 1 times 5 is 5. 5 plus 2 is 7. So those are 3 points on the original function. And now that I know that, I already know 3 points on the inverse function. 3 points on the inverse function. How do I already know that? Well, you just flip-flop your table here. And so 3 points on the inverse function would be -3, -1, 2, 0, and 7, 1. And if you graphed both this guy, plotted these 3 points, plotted these 3 points through the lines, they would have a reflection in that identity function y equals x. They would be reflected across that from each other, okay? So that's how to do that. And then I want to close, well, I don't need a board. I just want to say I want to close with this. A function and inverse function are big deals in college algebra and higher, trig, calculus, and on up, because, like, for example, the inverse function of the natural log, which I've talked about logs and natural logs, in the last 2 lessons. Well, guess what the inverse function of the natural log is? The inverse function of the natural log is your exponential function, okay? They're inverse functions of each other. And guess what the inverse function of log is? Well, the inverse function of that is 10 to the x. So those functions are inverses of each other, all right? So they too would have, have a reflection across like a line like that, the identity function, all right? And if you ever forget that, just look on your calculator, because on your calculator, what's right above the natural log in yellow? The exponential function. The reason why that is the case is because the exponential function is the inverse function of the natural log. If you forget what the inverse function of the logarithmic function is, just look on your calculator in yellow right above that is 10 to the x. Well, 10 to the x is the inverse function of the log, because what's the normal base for a logarithm? Base 10. And so, you kind of get a better understanding of that whenever you understand functions and inverse functions. So, hope you learned something out of that. Have a great day, have a great weekend, and talk to you on Monday.